All right, welcome back. Hey, so we're gonna finish off the script from last week, and we're gonna, do some of the things that I said we were gonna do, and really polish this script up. Because right now it's doing a couple of things well, but it still hasn't implemented all the different object types that I want it to. And we also need to get this padding, this O1, instead of just being 1, 2, 3. So we need a way to introduce some sort of number padding into this whole script, and flesh out some more of these different object types. So let's get into it. All right, so here I've got an example which we can use as a test case, because this is a little bit more complicated than just running it on a single cube. We have a bunch of different object types here. We have joints, we have constraints, we have transforms, these groups here, and we also have these controls, and of course just regular ass geometry. So we need to kind of figure out a way to automatically suffix all these objects. But on top of that, we also want to intelligently suffix these objects so that if it's already got the correct suffix, such as this, it's already got the correct suffix, tail underscore connector underscore geo. So this underscore geo part is what we want. How do we actually retain this suffix so that we don't double up on it? So we don't get something like underscore geo underscore geo. So let's try to attempt to address some of these things. And of course, again, I'm just freestyling this, freeforming it. So there's no real plan. I don't have any solutions for any of these things at all. So we're just gonna figure it out as we go. And this is kind of my approach when I start scripting. Is I see where there's issues and I see if I can find a solution for it, and then if we look at the code a little bit closer and I see there's a better solution, I'll sometimes go back in and make adjustments to the code itself. But a lot of the times I'm just kind of going with the flow and trying to solve each one of these little things one at a time. Otherwise it's a little bit too overwhelming to try to solve everything all at once. It's sometimes much easier just to kind of solve small little issues one at a time and combine it all together. So I've got all this code here which I've written already, and just so you guys know, you can actually access this code on our Discord channel. So I've pasted in a copy of this code from last week into the Discord channel, and if you guys wanted to just go there and grab this, you can. And by the end of this little video, I'm gonna put up this code, the finished version of this code, inside of the Discord channel. And we might not actually make it to a final version of this by the end of this lesson. It could very well only solve a few of these issues and might not be able to solve them all within a reasonable amount of time. So if not, I'll make another video where I kind of go through and try to finish it all off. But yeah, let's get into it so we can start scripting, start coding. All right, so the first thing I want to try to address is just this suffix here. Right now it's just doing 1, 2, 3, 4, 5. It's not doing this padding, this 0. And what I really want is to be able to, pad this somehow, so we get some sort of nice padding on the number, and we can also dictate how much padding we have, whether it's just padded with 1 0, whether it's padded with 2 zeros, and it really depends on your conventions, your style of numbering things. At different studios have different conventions for padding and naming. So I want this code to be kind of robust enough to be able to adjust that on the fly. So that's going to be done mainly in this get index section, because at the moment it's just returning an index. What we can actually do is take this index and perhaps instead of just returning the index, we run the returned index into a separate function, maybe named pad index, and then we can pad the index and return a string. So that could be a good way to do it. So that's what I'm going to do next. So I'm just going to define a new function. I'm going to call this pad index, like so. And then in here we want the index that we want to pad, and then we want to do something to that index. So the first thing we need to identify is how many digits are in that index already. And it's easy to, convert this, which is at the moment a number. So when it returns this, it's a number. what I want to do is take that number, convert it to a string. So we do string idx to convert it to a string. And there's a nifty little trick you can use with strings to determine how many digits in a string is you just get the length of the string. So if we do length string, it should give us however many, digits, I guess, in that. So just as a little example, if I come down here and just let's just do a number, let's just say 10 like this, right? So we call this my num is equal to 10 and run this. Now I can do something like string my num like this. And if we run this, it just converts it to a string there. You can see it's just got the quotation, so it's a string now. But when we do length of string, then we run this. Now you can see it says 2 because we got one digit here and another one. If I add, more digits here, like a bunch, just a bunch of random digits, and I run this, of course we got to print this. So let's print it. Now you can see we got 16. So if you count all this up, there'll be 16 digits. So just to make it a little bit more clear, we have 4 here. If I run this, it should return 4. So run 4. So that's how you tell how many digits there are already. And we'll use this number here to determine how many zeros we need to pad at the front. So let's come back to our code here. So we want to pad the index, but we also need another input of how much padding we want overall. So we can give it a default number. So maybe we want to pad it by 2. So we want 2 digits total, and if it doesn't have 2 in the total number of digits, then we'll pad it with some extra zeros at the start. So here we go. We can say digits is equal to this. And now we can say if digits is less than padding, then we'll take the index, we'll convert it to a string. So we make this a nice string, but then we also add, we add some zeros in front of there. So we add some zeros like that, but we want to do this in a smarter way because we need to get up to the number of padding that we have there. So, we need to do some sort of trick there. So how would we do that? So we already have the number of digits. We just need to take this somehow and pad it so that it adds up to the total number of padding. So we need to use padding somehow. So if we have digits is less than that, then we need to find the difference between the digits and the padding. Maybe instead of this, we can do something smarter. Maybe if instead of checking whether it's less, we can in fact do some maths ahead of time. So we say, we can say missing digits is equal to padding minus digits. So this will tell us how many digits away from the padding that we need. So if this number is 0, then we're good. If it's positive number, then that's how many digits that we're missing. And if it's a negative number, then that means that we've already got enough padding and we don't want to pad it anymore. So it's just a smarter way to do this than just to check this, because if we check this, we'll still need to figure out the difference. But this way, we're already figuring out the difference and we can use this instead of checking for this. So rather than doing this here, we can say if missing digits is greater than 0. So if it's more than 0, if it's a positive number, then we'll need to pad this. And then we can use something like this. We can take this string here, this number of zeros, and we can multiply that by missing digits. So this is a little bit of a trick here. So let's see if this works. And I think it will work. So if you take something like a string and you multiply it by a number, what that will do is just take that same string and append it to itself, n number of times. So it'll append it to itself the number of times, whatever this missing digits number is. So just to show you guys as an example, we can do foo is equal to, let's take something. In fact, I don't even need a variable. I can just say something like, let's use 0 as our example. So if I run this, you can see it's just one of these, but if I do 2 and run this, now you can see we get 2 zeros. If I do 3 you get 3 zeros. So that's how we're going to pad the front of our number. And what we can do now is if we plus and we say something like 1 as our like index, and you run that, you can see now we get some padding there. Now we can say, oh, okay, we got some decent amount of padding, and this can, help us really get there in a nice and procedural kind of way without having to manually punch in numbers. Otherwise, you won't be able to change this number of padding easily. We need some sort of way to dynamically adjust the padding. So we can pass a different number there and it'll automatically pad the thing as we need. So it's a little bit of a trick there, and I think that's going to work for us, and I'm happy with how this is going. We just need to store this as our do we need to store? Maybe we can just return this. In fact, we don't need to store this as a variable. Don't need to complicate things. Let's just return the result of this. So whatever the result of doing this operation, we'll just return that rather than trying to store it. And we can even, I think we can even return the index if it doesn't, if it's not greater than 0. So if we don't need to pad it, we'll still need to return the index somehow. And we should return, instead of returning the index, we should return the string of the index. So this basically takes in a number and it will pad the number and it'll return a string. So we're not returning a number in this, and that's important to note that the result of this, we're transforming the input type to a string once it comes out of here. And usually when you're doing stuff like this, you'd want to do some sort of type, some type checks, some typing, and really let the other programmers that look at this code know that, oh, okay, we're taking in a number type, like either an integer or a float, and whatever happens at the end, it turns into a string. But I'm not going to get into that right now because that's a little bit more advanced. Safe to say that we're taking in a number and we're returning a string, regardless of whether we're padding the number or not. So now we need to fit this function into this auto rename code somehow. So we're taking this and we're getting the index, and now we have the index. But after that, we want to get the padded, we want to store the padded index, and we use this pad index function that we just wrote, and we give it this index that we got, so that we pad this index. So now this becomes a string, and instead of using the index there, we use the padded index. And you can see my line's getting a little bit long. PyCharm actually has these borders here which help you see when your lines are getting a little bit too long. So when I get past this line here on the very far right, I know that I need to kind of organize this code a little bit nicer. This is a little bit complicated at the moment. So what I might actually do is take this whole operation here, and I'll just split it out into its own line. So I'll just say name, so this will become our new name. And I'll just put this entire string formatting operation here so that we get this name variable that we're storing, and then I'll use that name variable in the rename there. So this is just a nice clear way to kind of distinguish what is going on in the code rather than having these super long lines. I always see like new programmers, they try to do the most work on one single line just because like they feel like it's cool. Like, hey, look, I can do all this cool stuff on one single line, but then the line ends up being just ridiculously long, and it's not really practical for other programmers or even for themselves. When they visit the code later on, they're just like, what the hell is going on with the code? It's so long, and they're trying to figure out all the different things going on. So it's when you see that your lines are getting a little bit too long, a little bit too complicated, it's actually helpful to split it out onto its own line and just store all the result in the variable and reuse that variable. It's just a little bit easier to follow. So yeah, now we're renaming the object using our newly padded index. So we can give this code a try. Let's give it a shot now. I'm just going to select this, and right now we still haven't gotten it to work so that it'll read a shape node and rename the transform node automatically. It's still just looking for the mesh, because right down here we've only implemented a mesh type down here. So later on I'm going to have to change this code a little bit so that it gets the suffix in a little bit more intelligent way. It's not just looking at the selection. In fact, it'll take a selection, and if it finds that it's a transform node, it will automatically look one level down to see if there are any shape nodes associated with it. And then it'll automatically suffix the selected transform so that it gives it the correct suffix, like _geo. Because essentially, you know, these two things are the same. These are both transforms. The only difference between these two is that this one is, it's a group because it has nothing that's a shape node directly underneath it. Whereas this one is like a geometry object because it directly has a shape node underneath it. So it's not actually a group, you know, quote unquote. So what I actually want to do in this instance is to treat this differently than I would treat this. So we'd have to look at the shape. But right now I haven't implemented that, so it's not going to work if I try to test this code out. So I'll still need to select the shape node here and test out the indexing. So if I run this, okay, now I can see it's indexed it nicely. It's added 01_geo. And if I wanted to pad this more, I could change the padding here. So instead of 2 as a default value, I could say something like 3 and save. And now if I run this, I should get 3 digits in total. So it's padded to 3 digits. So that's kind of solved now this padding situation. So let's move on and actually try to solve this whole transform versus a group situation here that we have that I just talked about. So right now we're looking at our selection, and so we're going, okay, object suffix and object to rename. So if I come back to here, it's auto rename selection. So we're taking our selection, we're doing auto rename object. So it's getting the suffix. So we come down here and then we've got a suffix table here. So what I actually want to do is implement something a little bit different when we get to a transform node. So when we get to a transform node, it's not going to automatically use this suffix table. It's going to do something a little bit different first. So what we're going to do is we're going to say if obj, so if is instance obj is pm.nt.transform. So what does this mean? I'm just going to do pass for the time being. So if what we have selected is a transform node, so if, for example, if I just turn off shapes and I select this, if I run is instance transform, so is instance pm.selected, so what I have selected at the moment, pm.nt.transform. If I run this code, you can see it says true because what I have selected here is not actually geometry. It's not a mesh type. It's a transform type. Very similarly, if I select this and I run this, you can see it's returning true because this is also a transform type. And if I select this guy here and I run this, it's going to return false because this is a mesh type. So it's helpful to understand that this is a transform type. So it'll treat these two when I select them the same. But I want to distinguish this group from this actual object because this object has a shape node underneath. So I need to check if it's a transform type first. And if it is a transform type, so if it is a transform type, then I want to try to do something. I want to try to store the shape of this. So I'll do shape.obj.getShape. Now this is a little trick here. So getShape actually will look at the transform and it will get any shapes that are directly underneath it. So if I have this object selected, I can do pm.selected, get my selected object, my first selection, and I can do getShape like this. And if I run this, you can see it's actually gotten the shape node, this X ring shape geometry, this node type mesh. And that's kind of what I want. I want to see if I do getShape, if I get a mesh underneath, then I know that this isn't just a regular group. This is actually a container. It's actually an object that contains a mesh. So I'm going to treat this different now because I know that there's a mesh underneath. So we can do getShape and I can say if shape just means if this is not empty. Because if there's no shape, if I select this group now and I run get shape, you'll see the result. There's no result. See, it didn't return anything. So if I can say, if I just do type to see what type it returns, you see it says none type, because this doesn't have any shape nodes underneath it, directly underneath. You can see there's only 3 objects underneath there, and all 3 of these objects are transform nodes. You know, whereas if I get this and I look at the object underneath, this isn't a transform node, this is a shape node. So that's what get shape does. It looks directly underneath the transform and it tries to get the shape. And if there's no shape, so if there is a shape, now I know I need to treat this object differently. So what I want to do is, instead of using obj, I want to use obj. I want to store obj as shape. So what this would do is we're going to store the shape node as the actual object, and then we're going to go through the rest of this code, and then it's going to check the shape node, and it's going to check the suffix. It's going to get the suffix for the shape node rather than the transform node, and that's what we want. So this should theoretically work nicely now. So let's give it a shot. Let's give it a try. Okay, so if I select this guy and let's delete all that code. Let's not forget to save this actually. Now let's try run this, and instead of it just renaming this to, you know, it's gonna fail first of all if we didn't do all this, because we didn't implement the suffix table. So it's not even gonna give it a suffix. But now it should actually give it a suffix of _geo, even though we have a transform selected. So let's run it, let's see what happens. You see there, it's worked. And that's exactly what I wanted. Rather than having to select the shape node, it's actually done the renaming on the container of the shape. And that's perfect. That's exactly what I want. You can see now when I hit rename, auto rename, it automatically gives it the index as well as the _geo, which is beautiful. So we can give it a shot on this guy here. So this says tail. If I run this, now you can see it's tail 01. And hopefully if I select this one now, it's going to be tail 002 _geo. And it hasn't, because it's okay. So this is another thing now that we have to deal with, because it's already got a number here. It's unique to this one. So what we actually want is, we probably actually want to strip the remaining numbers from the name before we do the renaming, so that we don't get into this situation where it thinks it's a unique object already because it's already got, you know, some numbering there. So let's try to do that now, and let's fix this issue so that when I run this, it'll, instead of being tail 11001 _geo, it'll be tail 11002 _geo. So let's come back here and let's look at the name. So let's look at the name that we have. So we're using the name token, the first part of the name token 0. What I actually want to do is strip the numbers to the right of this before we format it back into our final name. So what I can do is say num stripped name. Let's do num stripped name. Let's do num stripped base name. So it's the number stripped from the base name. And we can say this is equal to name token 0. And what we want to do is do .r strip. Let's see if this works. R strip like this. So it strips the right, and by default R strip will, if it works, how it works is it works on a string. So if I string here and I say hello, and I put a space there and I do R strip, what this will do is just remove the space by default. You can see now it just gives me hello without the space, right? But if I have something else there, it won't strip that space. It's always looking at the right side, the rightmost side, to strip any empty spaces. You can see it didn't strip this space there, it just gave me the same thing. But if I add a few spaces back there and I run this again, you can see it strips all those spaces. And that's how it works by default. But we want to use this R strip to remove some numbers. So if I add some numbers there, what we can actually do is pass this a list. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, and maybe add 0 there and see if this works. Okay, so if I run this, Now you can see it's stripped anything that's within this collection of different numbers here. But if I take, for example, let's take out 1. So now I run this, so it won't strip out the ones. In fact, it hasn't even done this. Let's see, yeah, it hasn't even done what I wanted. Let's try this again. So it's stripped out the, has it stripped out anything at all? Yeah, it's definitely doing something that I didn't intend, but this, yeah, I'm not sure why it's doing that. I need to look into that. But when I add the entire table of numbers there, it'll actually strip out all the numbers, and that's basically what we want. So we can use this little piece here. So we can copy this, come in here, and let's replace this entire thing with that rstrip and save. So that'll strip the number out of there. And then instead of using this name token here, let's paste it here. So paste. So we're just using this num-stripped base name instead of the name token, because we've formatted this name token to remove all the numbers, numbers in the name first. So now when I run this code, let's remove all this junk. Now when I run this code here, it should do what we want. Let's cross our fingers and hope. And no, it hasn't. It hasn't up indexed. So we need to figure out why it hasn't added O2 here. And instead it's just added 1 there. Okay, so let's come back to our name. And now we're renaming the object. So what we actually want to do is check that this name, if this name already exists, then we need an up index. So let's see. And it could also be because when we're getting the index, so when we get the index here, we also need to, instead of using name token 0, we actually want the num stripped base name. So we actually want to take this num stripped base name, probably want to move it above the index, above getting the index. So let's add it here. And before we get the index, we want to get this num strip name base. And then we probably want to just adjust the name token 0 so that it's equal to num strip name base. Let's see if this works. And this is not, it's not happy. Tuple, it's because what we have here is a tuple. So we can't actually reassign a tuple. So maybe what we can do is make this a list just to make our lives a little bit easier. And we probably don't even need this variable, to be honest. We can just replace, we can just say, let's just take this entire section. Let's copy this and let's paste it there. So that just saves us to having to do that entire line. And then down here, we can actually just use name token 0 still, because we're just replacing name token 0. We're getting a little error here, and let's see what's going on. Why is this giving us a little error? Class list does not define get item, so the 0 operator cannot be used on its instances. Interesting. And it could just be to do with the fact that we are replacing this index as well as reading it in the same line. Maybe it does not like that at all. Alright, so maybe we do need to have this extra additional variable here to store it temporarily and then just replace that there. You know, not ideal, honestly, but it does seem like it's probably the only way we can get around that error. So I'm going to leave it in there like that. But I think this will solve our issue, because when we run the get next index and we pass this name token, inside of this name token, we've already done the numstrip based name. So we've removed all the numbers before we put it into get index. So when it uses the name token down here to generate a name to see if it already exists, it's going to find that it actually does exist and then do the index correctly. So let's undo here so that we go back to the tail 11, and let's try rerun this code and see if it works. And no, it still hasn't worked, so we still have to figure out what is going on and why it's not working. So if I come down to this code here, let's see, name token, passing name token back to index. So it's not up indexing correctly. And that's because we don't have the padding in this index here. So we actually need to pad the index during this get next index, which makes it a little bit trickier. So instead of padding the index down here and using padded index, we don't want this line at all. In fact, we want to use index here, but inside of this get next index, we actually want to pad the index during this whole process. So we have this index here, and then we come to here. What I want to do is to say padded index, or just padded IDX is equal to pad index, and we pad the index first, and then we use the padded index here, and we use padded index right there. And this line is getting a little bit long, so we can take this line, add it up to here, and just say name is equal to that, and then add name down there. So just using the same process of splitting it onto a new line, just so it's nice and clean. So I split it onto a new line there. And usually in these try except blocks, you want to do as little as possible in the try except blocks. So I'm actually putting the name and string formatting up here, and then I'm just doing all the formatting up here, and then just using a variable that I get from this process here. And that should work. I think this should work. And instead of returning the index here, I want to return the padded index, so that once this process finds the optimal index for this, we'll use that optimal index in here, because that'll return the optimal index there. All right. So I'm going to save this code and let's give it a try. Let's run this code again. And it's worked. You can see now it's 002_geo. So it's done exactly what we want. And this one should be 003_geo when I run it. And lo and behold, there it is. And now if I run all this, you can see it's automatically indexed them and it's added the padding. Beautiful. And in fact, I can just undo and just try to change the padding and see what happens. So if I select all this and come up to the padding here, instead of padding of 3, I want a padding of 2, and run this, and now you can see it's automatically added just 2 digits, and that's beautiful. That's exactly what we want. So it's a nice quick way to rename your objects. But right now we have to change the code here in order to change the padding when we run this script. Ideally, what we want to do is actually change the padding from this auto rename selection, so we don't have to dive in the code all the time here in order to change it. We can just change it here in a much more elegant, much more accessible and high level way. So this is just a default value at the moment. So I'll leave the default value at 2, but what I do want to do is actually have an input here saying padding is equal to 2 by default as well. And we also want to say that this auto rename object function has a padding of 2 as well as a default. So what we're doing is we're establishing a way to pass this padding into here. Then we want to pass this into the into this get next index, so that we're passing that padding there too, so that when it gets to here, it automatically changes this default value to use whatever we pass from the functions. So we're allowing this value to pass through all the levels of these different functions until it gets to this get next index, or the pad index, my bad, this pad index function here, which also means that we need to pass that value here, because this one will then finally call the pad index. So we need to pass this value into there. Padding is equal to padding. So we're taking this value, we're passing it into this pad index value. So we're using this padding there, and then it's coming into here, and then it's renaming that. So when we come up to here, we also need to pass it into, we can say padding is equal to padding. And then we can do the same here, padding, and we want to come down to get here, get next index, and we want to pass that value, padding is equal to padding. So now we're able to pass that value all the way down all the different levels until we get to pad index, which is exactly what we want. All right, so now we should be able to say padding here is equal to, so by default it's equal to 2, but we can, let's change it to something like 4 and see if this works. So now we should have 4 digits. So let's run this, and it's worked. Beautiful. So 0, 0, 0, 6, 4 digits, and we can add as many digits here as we want now. So I'm going to undo all this, and let's try something crazy. Let's do 10 digits and run. Now you can see, boom, it's gotten like 10 digits there, and that's exactly what we want. It's a nice, easy way to control how much padding there is inside of this script. Okay, so, and what if we had a whole bunch of these objects, and we reach up to a number of 10? Let's see what happens. If I run this, you can see it's still padded to 2 indexes, because it's, once it hits 10, it knows it's already got 2 digits, so it won't add any additional zeros at the front. So it's just keeping the numbers as is. And that's how you name the digits. Do the digits automatically. I call it lazy renaming. In fact, instead of auto rename, I should have just called this lazy rename, because that's what it is at the end of the day. It's a lazy name to rename things. And yeah, it looks like it's working well. All right, so I'm gonna undo till before I named all those. So at the end, I can do one big test where I just select all these objects, run the script, and see if it names everything nice and clean. Okay, so we've implemented meshes, we've implemented transform types that have shapes underneath. But what happens if we have a transform type that doesn't have a shape underneath? Well, let's come down here and see what we can do about that. So down here, we can actually implement transform type nt.transform, and we can say the default suffix for transform should be grp for group, so it's just a regular group. And if we get a shape and it has a shape, then we know it's not a regular group. It'll automatically use the shape as the object for the suffix, this suffix table. Whereas if it isn't, then it won't replace obj with shape, and it'll just be a regular transform. So it'll end up being a group there. So this should work now. And this already has underscore group. So if I run it, it'll do underscore group. You see, and that's not what we want. Like, it's even done the O1, which is quite unfortunate. What we really want to do is a way to just kind of remove this group first. We can strip that out and then have it be named something like this. So it's access geo underscore O1 underscore group. So it adds the index still. So how do we do that? Well, we need to figure out if it has this in the name already and automatically remove it. But before we get to that, let's just test the underscore group on something like this, which doesn't have any shapes underneath. You can see it doesn't have any shapes underneath there, but it is a transform, and it does have a base name already without anything at the end. So for something like this, it should already work. So when we run this script, you can see it's added O1 underscore group, which is exactly what we want. So maybe a good example is like this here as well. We've got some containers here, some geometry containers. We'll also have this transform node, this group node. I should be able to select all this now and run the code, and it should name all these things nicely. So if I run, you can see it's done exactly that. It's added o1 underscore group, but it's also done o1 underscore geo, o2, etc. And that's exactly what we want. So we're on the right track. We just need to figure out now how to bypass this doubling up of suffixes, and that'll help for something like this too. So if I run the script on this, we'll get an issue where we have a doubling up. You can see it's done underscore o1 underscore geo. So this here is not what we want. All right, so how do we fix that? Let's have a think. So we need to find out if this already exists. So we can use probably a string function, a string method called ends with. So if I have something here like hello world, and I do dot ends with, and I can do something like world. If I run this, it should return true. And you can see it has. So what this means is if this string here ends with this, then it'll return true. And what ends with means is if it's at the very end of the string. So if I put world at the front now, so if I do world hello and I run this, it should return false. You see, it's returned false because this string doesn't end with world. So that's just an easy way to see if something ends with something already. So we can use that to our advantage. We can see if the name already ends with underscore geo. And if it does, then we'll do something smart, like we'll strip the underscore geo first. Okay, so now we come here, we come all the way up. So we get the suffix. So we have the suffix here from doing this little script. And then up here, once we've gotten the suffix, we can say, hey, does the name end with the suffix? And if it does, then we'll strip it first. So right now here, we're getting the object, the node name of the object. I think we want to get the node name first and then check if it has the suffix in there, and then do all the rest of this code. So what we can do is come up to here, take this out, and we say original name is equal to that. And we can say if original name, we can say, no, that was right. Let's say if suffix, no, we can do if original name dot ends with suffix. So if the original name ends with the suffix, then what we can do is do original name dot rstrip. So we strip the suffix out of the original name, and this one can now become the original name. We can call this base name. How about that? We call it a base name. So now we do base name there instead. And you know, it's complaining because we were defining this variable under this if statement. So if this if statement doesn't end with that, then we won't ever define this base name. So what we actually need to do is also define the base name, regardless of whether the suffix is inside of this original name or not. And an easy way to do that would actually just actually call this base name instead. So we already have the variable that exists, and then we rename this to base name. All right, so this should work now. Let's give it a try. All right, let's see if this works. So let's remove that code, and we run the script, and now it's worked. It's removed the geo, but you can see it's also got the underscore there, which is not ideal. We don't want it to have this random underscore there, this double underscore. So we need a way to remove the double underscore. And I think an easy way to do that is, as we're stripping these numbers, we also try to strip this underscore and see if that works. So let's try that again. And you see it's done it because we're stripping the underscore first before we're adding the suffix back on at the very end. And the suffix will come with the underscore right there. So that's an easy way to deal with that issue. So I think we're doing pretty good now. We actually solved a lot of the issues, and I think what remains is really just to implement the rest of the different object types. So like joints, we need to implement joint types so that it gives the correct suffix for joints. We need to implement the suffix type for constraints perhaps, or maybe we can leave constraints. So if it's constraint type, we'll just skip it entirely. And locators too. So what do we do when we reach a locator? What kind of naming conventions do we want to use for locators? And here for NURBS curves, if you're doing rigging, then you probably want the NURBS curves to have something like underscore control, or you might want underscore CTRL depending on your naming conventions. So I'm going to go with underscore CTRL for NURBS curves. And let's quickly go through and try to implement some of this stuff. All right, so we just need to add all the suffix into the suffix tables or the different object types. So we've got transforms there. We can do pm.nt joint for joint type, and joints will be JNT, nice and simple. We can also do pm.nt NURBS curve. You can see down here there's NURBS curve, and for NURBS curves I want to do something like underscore, not underscore, just control, because we already got the underscore added in from there. So we just need control. And finally, we can do locators. So pm.nt locator, and we can use lock for locator. So this should actually implement all the different object types now. So let's give it a try. So let's select all this, and bear in mind some of these already have underscore group. So in the ideal situation, it'll strip that, it'll add O1 underscore group instead. And for these ones, it should add underscore group. Underscore O1 group, underscore O1 group there. It'll add underscore O1 tail underscore O1 joint, tail underscore O2 joint, and etc. etc. So, and we've got some locators there and some controls. So you should do all the right things for these. So let's try it. Let's select this control group all the way down to here and just give it a quick run and see what happens. And ta-da! Look, I think it's done everything right. Now it's got underscore O1 group, underscore O1 control, underscore O1 control. Look at that, it's done everything perfectly. It's done the locators perfectly, base tail, O1 locator. It's done everything perfectly. See, it's done the joints and it's named the joints correctly. Before it was just tail for all of these. Now it's tail O1, O2, O3, etc. And for all the stuff that had group in there, it just stripped the group first and then added the group at the end. So I can also probably just select all this stuff and run it. We haven't implemented constraints, so I'm curious to see what it would do for something like this. Well, let's run the code and let's see. So with a constraint, it's just treated it as a transform, which is interesting. So if I run pm.selected O1 type, or we can just do type like this and see what this returns. So it's actually returned parent constraint, but for whatever reason, it's named it group. So it's treated it as a transform. So maybe if we do something like, just to check what's going on here, we do is instance pm.nt transform to see if this parent constraint node is actually an instance of the transform node. And it is actually an instance of transform node. So I guess in the inheritance chain, it's actually it's a subclass of a transform. Excuse me. And that's interesting because that's not something I knew before, that it was actually a subclass of transform. And that's beside the point. I don't think it really matters too much. We could probably implement something special for that, but I might leave that for next time, or I'll let you guys try to figure that one out. But I think all in all, this actually works pretty well overall. You know, it's handling most of these object types that I have in here, and it's doing all the right things for this. And I'm very happy about that. And I think with that, I'll wrap this lesson up. And yeah, if you guys are curious about all the code here, make sure you guys check out our Discord channel. I've I'll put a link in the description, and you guys can actually grab this code from within the Discord channel. I'll paste it all up as soon as this video comes live, and yeah, you can take a look into it and see if you can dissect it and try to understand a little bit more. And you know, just so you guys, if you guys wanted a nice auto renamer like this, you wouldn't have to rewrite all this. You could just copy this code and maybe modify some of these different suffix types to your liking, and even change some of the padding types around here. But the idea is now I can just take this code, I can come to a shelf, for example, throw this on the shelf, you know, maybe give it a nice name. So maybe I'll call this in the icon label, rename. And now I can just hit this button whenever I want to rename something. So I can, for example, open this guy up. I've got these pose interpolators here, so it's not going to name those correctly. But if I find an object, let's see if I can find an object that needs some naming. So this one here doesn't have _01_ control, so I can hit rename. Now it's renamed it to the new convention that I want. And this one too, so I can rename, and you can see it's 01_ group. And it's even stripped this group down there, so it's kind of added a nice little naming, bonus naming thing there. And you can see this one's _02 control now. So it's just a nice, easy, lazy way to rename objects. That's why I called it auto renamer, because it's trying to do its best job at automatically renaming things, so you don't have to do it manually. And yeah, it didn't take too long to write. You know, I was fumbling around a bit trying to figure out some different things, but that's how it is when you're scripting. You just have to think through the problem and see what kind of solutions you can implement. And there's probably nicer ways to do this, but there's probably uglier ways to do this either. I think this is not the worst way to do it. You know, if I had to say, I think it's quite elegant in a lot of ways, and it's really easy to modify. So yeah, thanks for watching. Yeah, make sure you guys stick around.